Okay, this is to show you how to do a project with MicroBlaze. So again, you're going to do create new project, hit next, and then we're going to call this MicroBlaze example. Hit next, choose RTL, hit next, make sure it says VHDL here. Next, 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 and then here you want to hit Matrix 7. CSG 324 -1, and then pick this one. Hit next. Finish. And it'll create the project. So now we need to create a block. So we're going to use IP. So we're going to create a block design, and then we're just going to call this system. Hit OK. And then we'll create the IP source. Now we're going to add the MicroBlaze, so we're going to click on this, and then here we're going to type micro, and we're just going to add MicroBlaze. And then we're going to run block automation. So if you're doing your own project, you need to set this for what you want. For this example, we're going to set this to 32K, and we're going to put debug and hit OK. Next, we're going to double click this clock wizard. And then we're going to change the primary to single-ended clock table pin. And we're going to click OK. And then we're going to run connection automation again. And just check all these. And hit OK. And then if you want to regenerate the layout so it's cleaner looking, you hit this. And it should show you all the connections that you have here. It should look something similar to this at this point. The next thing we need to do is go to Titanium and download the constraints file. So that's going to be in Titanium. I have a file there that has the constraints on it. So it's under Labs, this DDR master constraint file. You're going to download that, and then I would download it into the same folder as your project. So mine's in users, JFoller, Auto projects, and the example. I'll just put it here. Download that. And then what we want to do in sources is we want to add the constraint file here. So what you're going to do is you're going to add sources. Make sure it says added constraint. Hit next, add file, and then you need to navigate to that location again. So it's C drive. If you're using Windows C drive, users JFoller for me. JFoller, it may not be JFoller for you, maybe whatever your username is. And then you're going to go to project and add that file. Hit finish, and it'll add the constraints here. Let's go ahead and open this. So it has all the predefined constraints in there. So the first thing you want to do is uncomment these first two lines, and then where it says this clock 100 megahertz, you want to change it to say clock RTL. So in here we're going to put clock RTL, and then also in the other one here we put clock RTL. Next, we want to associate the most significant switch on the board to this reset. Sorry, I mean this reset. We want to associate it with this reset RTL. So in there, you're going to change switch 15 to reset RTL. Oops. And then finally, we want to put one of the push buttons on the board to be to the reset, his other reset here. So this is an external reset switch, which will restart the program. This reset switch will reset the MicroBlaze. So we could just pick any of these buttons. I'm going to use the center button, which is BT and C. And uncomment this, and we're going to call it reset RTL 0. Now the names that come out of the automation may be slightly different, but you just need to make sure that you use the ones that are connected in a similar fashion. So these names might be slightly different for you. Next, in this hierarchy window, if you don't see it, just click on Project Manager and it'll pop up. So go to this hierarchy window and then right click on where it says system.bd and then put create HDL wrapper and you just let Bravado manage it and automatically. Just hit OK and it'll do it. Okay, now what you have to do is you have to run the implementation. You could just click on generate bitstream actually, but I like to run implementation first. Make sure everything's okay. Oh, one other thing too I forgot to do. Inside your IP sources, what you want to do is probably want to validate. So you can click on this and run validation, and it should say successful. Next, run implementation. So I'm going to go ahead and click on this, hit OK, save, and then this may take some time. So you're going to have to let it do all the place and routing and all the synthesis. And you can see its progress here. If you go down to this window to design runs, you can see that it has it all queued up. Also has the implementation queued up, and then you can also see up here its status on what it's working on. So you can open the implemented design if you want. I typically just go straight to generate bitstream because that's the next step you need to do anyway. So I'm going to go ahead and generate bitstream and hit OK. And then this will start the bitstream generation. You can see the progress here and up here. And this will take a few minutes, so just wait. So at this point you can look at the implemented design or view the reports. You don't really need to do any of this, but I'm going to open the implemented design. It'll show you how it gets laid out on the FPGA once it's downloaded. So at this point it's not downloaded yet. And unlike the VHDL example where you would go down here and program it, we're not going to program it in Bravado. We're going to program it in SDK. So this is showing the layout. Just close that if you want. So what I was saying is that typically what you would do in the other one is you would open the target and then program it. You don't need to, you're not going to do that here. What you're going to do here is you're going to go to File and you're going to export hardware. So we're going to click on this. You're going to include the bitstream, hit OK, and it'll export it to a file. And then after that, what you're going to do is launch SDK. By the way, if you don't see this launch SDK, you probably didn't install it because by default, when you're installing, the SDK isn't selected, so you need to select that. If you installed it and you didn't select it, you don't need to uninstall everything and reinstall. What you can do is you can go here to Help, and then you can add design tools or devices and choose SDK. Alright, so I'm going to go ahead and launch the SDK. It's going to ask you this, just leave it default, hit OK, and then it will open up Eclipse. So it takes a few minutes, so just give it a second. Okay, once Xilinx SDK opens, which is also just Eclipse, it's the same thing as Code Composer basically, just customized for the FPGA. You may see it like this, or you may have something in here that has like a button that says create a new application project. Either way, you can click on that button or you can go to File, New Application Project, and it'll open this menu. You need to give it a name. I'm going to call it Hello World. You can call it whatever you want. Everything else will just stay default. And then click Next, and then click Hello World and click Finish. And it'll create the project for you. This may take a little bit. Okay, and then now in your Explorer you'll see three things. You have the hardware wrapper, just leave that alone. You have the BSP, you'll leave that alone as well. In here you go into Hello World and the sources and open hello world.c, and then this is where it is going to print out Hello World. Next thing you need to do is create the configuration. So you're going to go to Run Config. It should already have the GDB configuration highlighted. You need to make sure that you have the right application. It should say Hello World here, so you can click Browse and click on Hello World, and then debug should say hello world.elf, or whatever you named your project. So like if I call this test, it should say test and then test.elf. And then inside the stdio connection, you want to make sure it's JTAG. You want to hit apply and then close, and then what we could do is we can run it. Oh, before you run it, you want to program the target, so you want to go to Xilinx tools and put program target. and then you should just leave everything default. Hit program, and it will write the bit stream to the FPGA board. So this should take a few seconds.
Okay, if everything's successful, you should have the Eclipse window open with the Hello World C code there. And then on your board, this switch here is going to be used to reset the CPU. So depending on how you set it up, it either needs to be up or down. So if it's in the wrong position, you'll get an error. So I have it purposely in the wrong position, and then I'm going to go ahead and run the code. What you'll see is that I'll get an error. I get that red error and some message like this. So what that means is that you need to flip the switch the other way. So if I flip it the other way and then rerun it, it should output Hello World. So let's see. It should output Hello World down here. There, it's done.